Hi guys, myself Ankita. In this video, we shall see another problem on LeetCode. First, bad version. You are a product manager and currently leading a team to develop new product. So unfortunately, the latest version of your product fails the quality check. So since each version is developed based on the previous version, all the versions after a bad version are also bad. Suppose you have n versions from 1 to n and you want to find out the first bad one which causes all the following ones to be bad. So what do they mean is there are bad versions, okay? So let's say there are versions from 1 to 8, 5 then 8. And let's say the fifth one is the first bad version. So all the versions 6, 7, 8, all the versions 6, 7, 8 after the first bad version are all bad versions. And that is what they have told here. And you have to find the first bad one. So if all are these as the bad versions, then you have to find the first bad version. That is 5 has to be written as the answer. So you're given an API bool is bad version of version which returns whether version is bad. So how do we get to know whether a version is bad or not? They're directly given an API. We just need to call this. So which returns whether the given version is bad or not. So implement the function to find the first bad version. Should minimize the number of calls to the API. So our main intention here is minimizing the number of calls to the API. That is the function. How do we implement that function to find the bad function with minimum number of calls to the API? So usually the linear search could be applied. So we could apply from 1 to n, we can iterate over it, and whichever function gives as first as a bad, I mean answer as 0 or like negative, then you just return that particular answer as the first bad version. But they have told they have to minimize the number of calls to the API. So best method which comes to our mind, since the numbers are in the ascending order, sorted order, we could use the binary search method here. Yes, we could use binary search method. So first we will have the numbers 1, 2, 3, 4, 5, 6, 7. Okay. So binary search, as we know, one point will be left and other pointer pointing to right. And we have to calculate mid. So mid will be nothing but left plus right by 2. So let me just write the indexing. 6 plus 0 by 2 will be 3. So mid will point here. And here we cannot just do mid equal to left plus right by 2. So mid equal to, usually what we do is left plus right by 2. So we will not use this. We will use the other method because this will cause an integer overflow. What if left and right are something that is maximum and it will cause an overflow after the addition of the two numbers. So what we do is we use the formula left plus right minus left whole by 2. So what does it mean? So first we do right minus left. See, right is 6 minus left 0. That will give you 6. 6 means right minus left will give the size of the current batch. So size of the current batch from left to right, it will give the size. So first we need to find the size. 6 minus 0 is 6. When you divide it by 2, it will exactly point to the middle index, right? 6 minus 0, 0 by 2 by 3. It will point to the third index. So from left we have to move till the third index. So we do left plus 3. That will point to this particular number. So 6 minus 0 will give you the size. If you divide it by 2, it will point to the middle index. So from left, you have to move till the middle index. So left plus the middle index, that is 3. So 0 plus, left is pointing to 0 plus 3, so that will give you 3. If in case left was pointing 1, okay, 6 minus 1 will be 5. 5 by 2 will be 2. So 5 by 2 will be 2, right? So from left, you have to move 2 pointers. So it will point to 3 again. So that is how we solve the problem. So once you get the middle, now we have to check, we have to call the function is bad version of mid. So is bad version of mid. So this is a function. So if this returns false, what does it indicate? If this returns false, what does it mean? All the numbers, all the versions next to this value are false, that is for sure. So this we can cancel, and this also we can cancel. But what about the number previous to this? This can be either bad version or a good version, right? It can be either a bad version or not a bad version. So there are cases. So what to do? We initialize right to the mid, not mid minus one, because mid minus one we are not sure whether mid is the first bad version or not. If there is a bad version previously, so since we are not sure about that, we do right equal to mid. So right will point to mid. So got the reason why are we just assigning right equal to mid? Because we are not sure whether the 3 is bad version or not. It can be a bad version, it cannot be a bad version. If this is 3 is not a bad version, then 4 is the first bad version itself. So in such case, you should not move further back. No? So that's the reason. So once you get right, again left plus right by 2. So in this case, 3 plus 0 by 2 will be 1. So mid will point here. Now, in case if is bad version of mid, that is pointing to this element, if this gives false, if this is not a bad version, then what do we need to do? So one case we got to know if the given number is a bad version, we just assign right equal to mid. If given number is not a bad version, then what we need to do? We should, that means this number is not a bad version, so the bad version will exist after mid, that is for sure. So what we do is left equal to mid plus 1. So this will be left. So left equal to mid plus 1. Because in this case we are sure this particular 2 second version is not a bad version, because we are pointing, it is pointing to the mid, and that particular version is false that it has given. So it is not a bad version. The number next to it only can be a bad version. Next after the mid. So we assign left equal to mid plus 1. But when it comes to the right, we assign it to mid, because there are chances where mid also can be a bad version and a number previous also can be a bad version. The number pointing at mid only can be the first bad version. So that is the reason. So we'll implement the program. So first binary search, right? So int left equal to 0, then int right equal to n minus 1. And yeah, at last, which will be the answer? The answer will be pointing to, so it's like a cross logic. Since right, if this is pointing to bad version and left, this is not pointing to bad version. So once the index crosses, left will be pointing to bad version and right will not be pointing to bad version. It will be either pointing to or not pointing to bad version. That is how the logic is. While left lesser than right. So first we calculate mid equal to left plus right minus left by 2. Why are we doing this? Because to handle the integer overflow. So if is bad version of mid, so if it is true, then the right will be equal to mid, else left will be equal to mid plus 1. So at last return left. Okay, so this should be equals. Yeah, I was thinking so. One second. See, since well, lesser than right is fine, and since the number is ranging from 1 to n, I have to give 1 to n. That is where it is showing false, because 0 is not at all in the range. That's why. Yeah. And for Java also, same logic and same program, nothing changing any syntax. So we'll submit this. So okay, here there should be one bracket. Yeah, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with another video in the next session. Until then, keep learning. Thank you.